Welcome class. I still remain Jude Anadozie. We are still on vectors and vector addition. Yes, in part 1, I was on vector addition before my memory of my gadgets was almost filled up. For that was what made me to shut down. So be on see on that. Uh, then there I said if this is vector A and this be vector what? B, and this be vector what? C. Let me just use A and B. Set the resultants picking of vector A to the ending of what? Vector B. So vector C equals vector A plus what? Vector what? B. But here I want you to take this caution. It is a common error to conclude that if vector C equals vector A plus vector B, then the magnitude of C should just equal the magnitude of A plus B. No. For example, you have these 3, you have these 4 meter, 3 meter. You know, if this being at right angle, it's a right angle, the displacement using Pythagoras is going to give us what? 5 meter. How did we get that? Okay. So for the fact that we say the vector of A, vector of A plus vector of B is vector of C, doesn't mean that the magnitude of A and B, summation of magnitude of A and B will give you magnitude of vector C. No. Except in a situation where A moves like this and B moves like this. That's C, beginning of A to the end of C. You have, except in this condition, that magnitude of A plus magnitude of B will give magnitude of what? Vector what? C. Outside that, there's no that scenario where the magnitude of A plus magnitude of B will give you magnitude of C. But the vector sum of AB, vector, take note, then I use magnitude. Magnitude of A and if it's A and this is B, magnitude of the sum of magnitude of A and B is 7. And magnitude of C here is what? 5. They are not equal. But if it is 3 and 4, here C will give you what? 7. Because here is on a plane. Here is possible. They are as if it's parallel on a straight line. But when there's an angle and they are not the same direction, it won't give you the same value. Hope you are with me. So outside that, let's see an example. Let's see an example here. It's okay. A cross country, a cross country, a cross country skier skills 1.00 kilometer north, and then 2.00 kilometer east on a what? horizontal what snow field. Full stop. How far? How far? And and in what direction? In what direction? In what direction is she from the starting point? From the starting what? Point. Now, to solve this question, you really need to understand that a cross-country skies 1 kilometer north and then 2 kilometer east. Let's assume it's a starting point. 1 kilometer north, it moves like this 1 kilometer. Then at this point, now move 2 kilometer eastwards. 2 kilometer east. And stop. They say how far and in what direction is she from the starting point? This is the starting point. So the resultant will be in this direction. So here will be the resultant displacement. So then, and in what direction is she from the starting point? Direction, we're talking about this angle from this is the starting point. Let's call here theta according to the Greek word. The Greek name for that symbol. So to get the displacement, you are going to use Pythagoras. Why? Because here is what? Perpendicular. North, and after north, you now move directly what? East. Not northwest, not south, northwest or northeast. So getting this and going ahead with our solving, the resultant, let's represent with letter R. Letter R square will give us what? Square of 2 plus square of what? 1. So R square will give us what? 4 plus 1, which equates what? 5. So R now will be the square root of what? 5. So taking away what? The square root sign. Which should be approximately 2 point what? 24 what? Kilometer. 2.24 kilometer. So that is how far he is from the what? Starting point. Now trying to get direction. What direction? This is the starting point. What direction is this ending part? What direction is this? So from the starting point, so at this point, here is our opposite, the part facing the angle. Then this is our adjacent. Then this is our what? Hypotenuse. So I'm going to use the opposite and the adjacent, talking about what? Tangent. Tan theta. Opposite is what? 2 kilometer. And adjacent is what? 1 kilometer. So we have what? 2 over 1, which is what? 2. So then getting the tan inverse of 2 will give us the direction, which is what? At what? 63.4 degree. 63.4 degree. So what direction is it from the starting point? He is now to 63.4 degree northeast. 63.4 degree what? Northeast, or east of what? North. This is north. This is north. This direction is east. This is east. This is north. So north, from north towards going towards the east at what angle? 63.4 degree north east. From north to east, just move 63.4 degree Celsius. Are you getting me? So think of east of north. East of what? North. But this is your north and this is your east. So east of north. But if I'm going to pick here, if I'm going to pick here, you do 90 minus 63.4. 90 minus 63.4 degree. This will give us what? If you solve it, to give it 26.6 degree. Time here is 26.6 degree. Now this is now what? Now this is east, right? This is now need to be what? North of east. North of east will be 26.6. While east of north is what? 63.4. Please take note. Take note. Take note. Uh, yeah, I'll be stopping on the subtopic vectors and vector addition under vector addition. So next video we're expecting to look at what components of vectors, the vertical components, what how we can get the vertical component of a vector, and also what the horizontal component. And where you have more than one vertical component and more than one horizontal component, how can we resolve them? So that will be what we'll be looking at in our next video. For now, stay glued to the channel. I promise to be uploading the videos every day, but so sorry for almost a week I didn't upload due to power challenge, and I have no alternative for now. But when I have alternative, I'll make sure what I keep to my word, to my words. So for those who are having challenge with this, start with my first video, the part 1 of this. Then look at this part 2. I believe everything is broken down to what? To a very simple form that anyone can what understand. But should the case you have anywhere you have a challenge, let me know in the comment section, and I promise I will attend to it. For those who still have other topics I should touch, please let me know in the comment section. Let me know. You can contact me. You have my mail. I will soon include my phone number so that you can get me there, and that will be also be my WhatsApp line. Contact me so that after I'm through with this vector and vectors, I will now move to that point. So we'll be covering, after the next will be what? Components of vectors. After component of vector, when I'm through with that, I will dive into what? Unit vectors. The unit vector will come after components of what? Vectors. Then after unit vectors, what will be expecting? We'll be expecting what? Products of vectors. We'll look at scalar products, and we'll look at calculating the scalar product using what? Components. Then after that, after scalar product, we'll now move to what? Vector products, and calculating the vector product using what? Components. And at that point, that is where we are going to what? Stop. And I believe if you stay to this channel, at the end of this topic, you should have no issue concerning this what? Topic known as what? Vectors. Thank you and remain blessed. If you haven't subscribed, please do subscribe. Invite your friends and colleagues and let them know about this channel. Thank you.